data, right? So once you get the data, all right, so it is very, very important before you start your analysis, data analysis, you need to know how to organize your data, right? So organizing the data can be divided into two. So I already mentioned this one in our previous class. So we have ungrouped data where also we need to group the data. Okay. So for ungrouped data, when we have a very small data, okay, in statistic, when we say small data, the n, okay, n is number of data, right? So n is actually, so that's the reason it is n, we use small n. When n is less than 30, so we can say small data set, right? And then if we have more than 30, when our n is more than 30, so it means that we need to group the data to organize it, to make it easy for us to analyze it later, right? So, for example, you have data 1,500. So this one is quite a lot, right? For you to calculate manually using calculator and so on. So that's the reason, okay? We need to group the data, to organize it, to group it, all right? So it will be to make things easier. And also the best way is actually to analyze large data is actually using the software, right? I already also mentioned this one, that we are going to learn in this class SPSS, right? So now your job is to install SPSS so you can get it from UTM ICT, right? Or you can also buy it, okay? Because this is what my students, the postgraduate students, told me, that you can even buy it from Shopee. So it is very not that expensive. It's about less than 10 ringgit, about or 10 ringgit. But if you want it free, you can get it from UTM. So this one is actually the statistical package for social science. Okay. So we are going to use this one also, um this software, after we have done our chapter 4. Then I'm going to introduce you how to actually use SPSS, right? Right. So next one on page 27, this is what we are going to learn. All right. So the measurements. So you have heard all these words, these terms since your school days. All right. So we just need to do some revision. Okay. From your knowledge, your previous knowledge. Okay. So for you to reapply in this class and also in your FYP, right? So I also have mentioned about this central of tendency measurement. So why does it call a central tendency of measurement? Because we hope that these three measurement, these three values, they will be at the center. They tend to be at the center in order to make things balanced, right? So I told you about this bar. Let's say we have a bar. So in order to make this bar balanced, so we must have the mean, the mode, and also the median at the center. So if they will the value or the measurement at the center, so we can say that our data set is balanced. So what does it mean by balance? The good and the bad will be even, equal, right? And then the next word that I would like to introduce you is actually the word variability, right? So variability is sometimes also called, known as distribution, and also dispersion. Those are the words that actually represent the word variability. So it means that you have different kind of data and you would like to see how it looks like, okay, when you draw it on the graph and so on. So distribution, okay, distribution is actually how the shape of the data can form later, right? And dispersion in terms of the location, whether is far apart from each other or they are very close to each other. So in Bahasa Malaysia we call this one taburan, okay, for the distribution, and the dispersion is serakan, right? So just in case. So all these measurements, okay, range, quartiles, percentiles, standard deviation, variance, skewness, coefficient of variance. The purpose of all this measurement is actually to tell you more about the dispersion and distribution of your data set, right? So let me give you an example, all right? So we already talked about this one, the mean, okay? Remember, the symbol is X bar. The median is X, like a yin and yang, okay? And this one is actually, we call it X hat, or it's actually like a mountain. So this is the peak, the highest, all right? Okay, so and we already discussed about this one, mode, when we have no mode, unimodal, bimodal, and also multimodal. Okay, we already discussed this one. And this one, okay, you can find, right? You can find the summary table. So the summary table for this one on page 28, okay? So you need to see, okay, when is actually the measurement is suitable for what kind of quantitative data. Okay, so for example, you have each monthly salary, okay? So the data is interval or ratio. Intervals means I will explain when we use SPSS, okay? So mean can be calculated, okay, if you have age. So you can say the average of the age, the mean of the age, the employee's age, all right? So we can represent by number. So all this is actually for quantitative, right? So the mean is suitable for quantitative, right? And then we have mode, okay? So mean, this is the mean X bar, the mode, right? X hat, and the median, right? This one. So the mode is actually more suitable when we want to represent, when we want to report about nominal data. So we can say how many people is actually in the supervision management category, job category, and also like blood type. So how many people is actually has, blood type A, O, B, and so on. So that one is nominal. And for median, it is more suitable when we want to report on ordinal data. So for example, satisfaction level, job ranks, and also CGPA, right? So this one, you can have it on page 28, right? So when you want to report later on, okay, when you want to write your report and also you want to write your thesis, so especially in your chapter 4, so make sure you use the right term, the right measurement for the right, the suitable data, right, or variable. Okay, so I would like to talk more, okay, on this one, okay, when we say measures of dispersion. So this one on page 28, right? So just write all the, all the information that I share with you, so at least you can refer to it after later, so it will be easy for you to remember what we have discussed in class. Okay, the next one is the word range, okay? Range, or we can also write it as R, right? So what is R? Okay, R is actually the highest data, the highest value in your data set minus the lowest value in your data set. So let's say I have this one, 1, 2, 3, 3, 4, for example. So then my range will be 4 minus 1. So the range will be 3. So the difference between the highest value and the lowest value is 3, right? So that's how you calculate the R. And then the next one, quartiles, okay, comes from what actually quarter. So quarter, when you divide something into 4 parts, right? So then we have quartile 1, quartile 2, and also quartile 3. So it means that from 0% until the end, we have 100%. So the center will be 50%. So quartile 2 will be, the value will be 50%, and quartile 1, 25%, and quartile 3 will be 75%. So if you look at this one, we can say quartile 2 is actually also, we can call it as median, because it always at the center that divide left and right equally, right? So that one is quartiles. Okay, people, if you have any question, please make sure you ask me. Otherwise, I wouldn't know whether you are okay or not, right? And then the next one, we have percentiles from the word percent or percentage, okay? So percentile, it depends, okay? It can be 5%, 20%, 70%, 75%. So it's up to the researcher how you want to divide your data. So for example, from here, you have the whole data set, okay? Usually we arrange the data from lowest to high, lowest value to the highest value, right? So let's say you want to divide your data based on this percentage, okay? This percent. So you can make it, like this one is, let's say 20%, 40%, 60%, 80%, something like that. So it's very what I is up to the researcher how you want to divide your data. Okay, and then the next one, a very very important measurement, which we call it as standard deviation and variance. Okay, standard deviation we represent by using small s. Okay, and then the variance is square root of standard deviation. So S squared. Right. So what does it mean by standard deviation? So standard deviation is actually the distance, right? The distance from, okay, from the mean. Okay. We call it mean because mean always, when our data is balanced, mean will be at the center and it will be our reference point. Okay. So for example, I have point A here and I have point B here. Okay. Which one is actually closer to the center or the mean? Which one is closer? A. Good, right? So I can say A is actually has lower standard deviation compared to the B, right? So standard deviation is like, measuring the distance from the center. So I can say A has lower standard deviation compared to point B. So, or I can say A deviate means, distance, so A deviate further compared to point B, right? So and then in order to calculate distance, okay, sometimes, okay, when we consider, okay, when we consider x bar as 0.0, okay, usually in coordinate system, when we have left side of 0, we consider them to be negative side. And for the right side will be positive side. But the problem is distance, we don't have any negative distance, all right? So usually we say it in the positive number. So for example, the distance from Kuala Lumpur to Johor Bahru is 376 kilometers. For example, we never say the distance from Johor Bahru to Kuala Lumpur is negative 0.76 distance. No. Usually positive and negative we use only for direction. It's not for distance. Okay. So in order to avoid, okay, in our calculation, so you can see here, how can we calculate the variance, okay? So we need to have, okay, the answer in positive number, right? Because it is represent distance. So in order to avoid, okay, the answer to be negative, that's the reason we need to square it in order to avoid negative number. So for example, if the distance A here is actually 2 centimeter, right? Negative because it's on the left side. So what I can do in order to avoid this negative number, I can square it. So negative 2 square will be 4, okay? And then in order to know the exact distance, what I can do is square root of 4 is actually 2. So this is actually the right answer when you want to say, if you want to represent standard deviation. So what I can say, the standard deviation is 2, or I can say the distance is actually 2, right? From the center or the mean. Okay, faham ke tidak? Can you understand? Aiman, Nadira, can you understand me? Faham ke tidak? Okay, very good. Okay, how about orang lain? Nusyafika, faham ke tidak? Okay, thank you, Zian. Right. Right, so the most important you need to remember, standard deviation, we try to avoid having a negative number, right? It should be positive. Okay, so this is the formula for finding variance, okay? In order, the first thing is good for us to find the variance first, and in order to find the value of standard deviation, once we get the answer for this one, what we can do is actually we just square root the s square. So we will get the s, right? And in the formula, okay, so you can see s square is 1 over n minus 1, sum of x square minus sum of x square divided by n, right? So this symbol, right? This symbol right here is actually sum. It's like S, okay? Sum, right? And then so we need to know how many data do we have in the data set, and also this symbol right here is not the same. Okay, this is not the same. So this one where you need to square each value first in the data set, and then you sum it, right? And then this one you need to sum all the values first, and then you square it. So these two number will be totally different. So even it looks like it looks similar, but it does not, right? Okay, and then we'll do example after this. Okay, and then the next one is skewness. Okay, the most important thing to have is to have a balanced data set. All right. So when we have balanced data set, so it means that the negative side and the positive side will be almost equal. But and then okay, what we need to have, as I told you earlier, so the mean, the median, and also the mode should be at the center. But if one of these measurement is no longer at the center, so we are going to have problem in terms of balance, all right? So it will be called as skewed. So it can be like this way, so it's skewed, okay? Or it can be this way. So for the balanced one, usually we use this normal curve to represent the balance or the balanced data, all right? So this one, the mean, mode, and also median at the center. But if one of these mean, mode, and median no longer at the center, sorry, median always at the center, yeah? Median, it will always divide 50% on the left, 50% on the right. So if we have, if one of these measurements is no longer at the center, it will be skewed, right? So it can be skewed on the left. Okay, we have center. And then we have something like this, right? Right. So one of the ways to check, okay, is where we need to draw, okay, the data, all right, the data set, and then we look at the shape, right? So if this one, right, so if this one, this one happened when we have, okay, the mean. Okay, the mean is no longer at the center, but it will be somewhere around here. So this is the mean. So this is the median, always in the middle, and the highest peak is the mode, right? So if we have something like this, right? So this is the mode. So we have median always at the middle, and the mean will be on the right side, okay? But if we have a balanced data, the mean, mode, and also median will be at the center. Okay, so this one, what do we call it? What kind of skewness, right? So if you are climbing the hill, right? Okay, if you are climbing the hill from the left, so we call it as left skewed, okay, or negative skew, right? So if we are climbing, okay, if we need to climb the hill, right, from the right, so we call it right skew or positive skew, right? Understand? Okay, we can also check how steep is the hill that we need to climb by calculating the skewness value. So, which is called as SKP, right? So SKP, SK is actually skewness, and P stands for Pearson. Pearson is actually a mathematician who actually invented this formula, who introduced this skewness formula, right? A very well-known mathematician. So if you calculate by using this formula right here, okay, and you get your answer close to zero, then we can conclude that the data is actually normal, has normal distribution, right? So now we say this one distribution or taburan. So, and then if we have the SKP, the formula, we use the formula, and then we have negative number, so we can say that the distribution is left skewed, right? It has left skewness, right? And then if the SKP has positive number, so we can say it looks like this one, okay? The distribution look like this one, and it is right skewed, right? Okay, this SKP, this formula is using two different measurement. If you can see, the first one is using mode, and the other one is using median, right? So you can use either one, okay, as long as you have the value. So if you don't have the mode value, then you need to use the second one, okay? This one is actually S, right? So this is the first formula. This is the second formula. If you have all the information on the mean, standard deviation, and also mode and median, you can use either one. But let's say your friend use on formula, the first formula, and then you use the second formula. For sure the answer won't give you the same number, but they will give you the same conclusion. Okay, let's say if your friend got negative, if she uses the first formula, and you must also have negative if you use the second formula. As I said, the number will be different, but the conclusion will be the same. Okay, that's what we can say about skewness. Right. So, and then the next one that I would like to introduce to you all is coefficient of variation, or we call it as CV, right? So what is actually CV? CV is used to compare the consistency of several data sets, right? So for example, we have many data sets and we want to check which data sets is actually more consistent, right? So the formula that we need to use is standard deviation divided by the mean times 100. So your answer always in percent. So if your answer, you don't give it in percent, it means it's wrong, okay? So you need to convert it to percent, right? So this is the tips, okay? Data with lower CV is said to be more consistent, right? So I give you an example, right? What does it mean by consistent? Okay, we have graph A and graph B. Which one do you think is more consistent? Data in A or data in B? Which one is more consistent? Yes, data B. Because data B has less fluctuations, okay? So this one is very unpredictable. So we can say it is inconsistent. So therefore, the CV will be higher compared to this one. So the one with lower CV, we can say it more consistent, right? Understand? So let's say we want to start a business, right? So let's say this one is business number one, okay? Product one, and then this one is product two. So which one will you take the risk? Okay. Are you going to sell product one or product two? Yes, product 2, certainly, because the risk is more consistent, it's more predictable, right? Okay, so today what we're going to do, we still have half an hour, okay? So we are going to try some questions related to for ungrouped data. Okay, again, ungrouped data means when you need to organize small data set, which is less than 30. So it will be easy and simple to handle, no need to classify them. So the first thing that you need to do before anything else, all right, before you start your calculation, you need to arrange the data from lowest to highest. But some, actually we can also rearrange from highest to lowest. But for my class, I would like to standardize. Everybody needs to arrange the data from lowest to highest. And then we need to calculate the measurements needed. Okay, let's try the first one example. So this one on page 30, right? Okay, so this is on page 30, right? Okay. So what we're going to do, right? So we need to calculate the mean. Okay, the first thing is the mean, right? And then we need to calculate the mode and also median. Okay, so let's do this one. So mean is actually you need to sum all the numbers, right? Then we divide by n. So the first thing, how many data do we have? Okay, so 9, right? So we have 9 values here. So what we need to do, we need to sum all this number, 1 plus 9 plus 6 plus 7 plus, all right? And then 1 plus 9 plus 6 until plus 11. And then we divide by 9. So, okay, I want Ehsan. Ehsan, can you please calculate for me?
Okay, wait that.
Okay.
It's 67.
67. Okay. And then divide by 9. So what do you get?
7.4.
7.4. Is everybody okay with that answer? Okay or not? Right. Okay. So that's our answer for the mean is 7.4. People in mathematics, this one, it means something. Okay. So it means it's already proven, or we can say QED, right? So that's what it means, not just I simply use this symbol, right? Okay, so number 2 is to find the mode. Okay, in order to find the mode, okay, before this, as I said, we need to rearrange the number from lowest to high. Okay, can Haiza, can you please rearrange this number? Haiza, are you here?
Doctor, are you calling me?
Yes. Okay, can you rearrange the number 1? We start from 1, and then what is the next one?
1, 3, 9, 6, 7, 8, 9, 10, 12,
And
11, 12.
11, 12. Right. So don't forget to rearrange the number because otherwise you will make a mistake, okay, in your answers, right? So this is the new order of the data set. So we have 1, 3, 6, 7, 8, 9, 10, 11, and 12. Right. So in order to find the mode, right, the mode, so what is your answer? Can I get Zian? What do you think? What is the answer for the mode?
As for the mode, all of them.
Sorry?
All of them.
All of them, okay. So, Joey, what do you think? What is the answer? Joey?
I think it's no mode.
Why do you say it's no mode?
Uh,
Why, Joey?
because the
Okay, never mind. It seems that you are not confident with your answer. Let me ask Zulaika. Zulaika, what do you think, Zulaika?
Because there are no similar number, means like there are no repetition in number.
Okay, so because, okay, we can say actually the mode is no mode, right? Because the number is only occur once, so it doesn't, as Zulaika said, it doesn't, there is no repetition in any of the number. So that's why our answer is more suitable. We can say it as no mode, right? Zian, do you understand, Zian?
Yes, tutor.
Okay, good. Right. So number 3, to find the median. Okay. To find the median, okay, there are 2 ways. Okay, one way is actually, I can say, is it looks like traditional way, but it's clever. The other one is modern ways, but it's not that clever, right? So let me copy down our one. We have 1, 3, and then what else? Our number 1, 3. Okay. Can somebody repeat the number 1, 3? We have what?
6,
6, 7, yeah,
8, 9,
8,
9,
10,
10,
11,
11,
10, 12.
right? Okay, so for the median, the traditional way, but it's actually is good, all right? It's clever because we tend to avoid doing mistakes, right? So the first thing we know that the n is 9. Okay, n is 9. So what we are going to do, we know that median is always in the middle, right? So we can divide, okay, this way, right?
Right.
Here, it match with this one, and this one, left and right, okay? So this one and this one, or you can put it this way. It will be easy, okay? Here, this one, here, 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 here. So what's left will be in the middle. So the answer is 8. Right? Yeah.
Right.
Yeah, that's the way that I said is looks very traditional. It looks not that clever, but it's clever. All right. So the next one, the other way of doing this median, to calculate median, the first thing we need to find, okay, the center, okay, right? So by dividing, let's say we know n is equal to 9, therefore the center, half of it will be n minus 2, which is 9 minus 2. will be 4.5. So this one is actually not the answer of our median yet, right? This is only the location, center, or location. This is only the location. Then from the location, we identify who is actually at the 4.5 position, 4.5. So this is the first position, second position, third position, 4, right? But the problem is when I say 4.5, okay, sorry, I got the, sorry. Okay, the wrong formula. Okay, should be n plus 1, right? So n plus 1, so it means that this one, 9 plus 1 will be 10, right? So is in the fifth position. So 1, 2, 3, 4, 5, fifth here, right? So this one 6, 7, 8, and 9. So it means that at the location, the fifth location will be actually number 8. So our median is 8, right? So that's how we get the answer. So it's up to you whether you want to use this way or not, okay? But the other one, okay? So let's say I have 1, 2, 3, and 4. Okay, so what is my
Medium.
yeah, my median? What do you think?
Okay, doctor, you first. Yeah, it's two formulas. Actually, there are gonna be two medium.
Sorry?
There are gonna be two, not one.
Okay.
Okay.
Yeah, not really. Okay.
No, like two formulas first.
Okay, two.
Yeah,
Okay, so we
the
have
first
the
one
first.
is n divided by 2, and the
Yeah.
other one n plus 1 divided by 2.
Okay, so actually this one, you can do it the traditional way, here and here. Okay, but the problem is when you take this one out, okay, you left in the middle 2 and 3, correct?
Yeah.
So this is what happened. So you need to find the average between these two. 2 plus 3 divided by,
The plus 2, yeah.
so we have 2.5. Actually, the median will be 2.5, right? So, and then if you are using this formula right here, okay, the next way, the next method, so we need to find the location. So we have 4. So, and then, so we have 4, okay, the location. So will be 4 plus 1 divided by 2. So the location will be 2.5. Okay. So it will be, this is the first one, second one, third, and 4. But the location of our median will be between these two numbers, 2 and 3. So we need, again, we need to find the average between these two numbers. Okay. This is an example of how we can calculate the median. Right. So next one, a very quick one. Okay. If you look at page 31, right? So we already find the mean, mode, and also median. The next one we need to find D here, right? So we need to find the range. This one is very easy. The highest minus the lowest. So we have 12 minus 1. It will be 11, right? So, and then we need to calculate the variance, okay? The variance will be sum 1 minus n, right? Sum of x squared minus sum of x squared divided by n, right? So, and then we need to find the sum of x squared and sum of x. So this is how you do it, right? Okay. Okay, for sum of x squared, so you need to square the number first. Square 1 plus, do we have 2? Yeah, 2. Okay, so we don't have number 2, we have 3, okay, plus, and then we have 6 square, and so on until we have 12 square. So you need to add all these up, right? The second one, you need to add 1 plus 3 plus 6 plus blah blah, and then 12, and then once you get the answer, right? So for the x square, so once you get this answer right here, you need to square it, right? So that's what you need to do in order to find the the variance. Okay, so for the x square, Fakrun, I would like you to find out what is the sum of this one, the answer for this one, and sum of this x square. I would like Atika to calculate for me. Okay, Nur Atika Osman.
Sorry, can you repeat for x square, right?
Sum of x, okay? Campurkan dulu all this number,
Hmm?
and then once you get the answer kat sini, and then you square it, right?
Oh, okay.
Fakrun, can you get your answer, please, for the first one?
Okay, give it.
Four, 8, 9. Okay, like that. Okay, so it will be easy for me to. Okay, I can see many people say 605. Is that correct? 605, yeah. All right. So now we can calculate. All right. So we can calculate the value. Okay, so we have, in order to find the s, okay, s square is actually, so we have 1, 9 over minus 1, okay, and then we have 4489 minus 6730, 605 divide by 9. Okay, so and then what you can do actually, if you use calculator, if you are good enough at using calculator, you can calculate this one shot. But for those who are not really familiar how to calculate, you can calculate one by one. So the first thing, you calculate this one first, and then once you get the answer, deduct from 4489, and then you divide by 8. Okay. So, Sabrina, can you please give me the answer?
Doctor, sorry, but I think the position of 4489 and 605 is terbalik.
Yeah, it's the other way.
Okay. Let me see. Yeah, okay. I think it's correct.
But the 4489 is the EX bracket square, right?
Uh-huh.
Then it means 4489 should be at where 605 is.
Yeah. Because this one is actually sum of x square. This one
But
is
tadi
sum
this
of
one
x
jawapan
square.
dia 4489. Yang bracket, yang ada bracket tu, jawapan tadi 4489.
Oh, okay. So, oh, yang kat sini
605 ah.
divide by, kat sini 4489. Yang
Ah.
tadi 67 square.
Yes, correct.
489. Is it?
Yeah.
Okay. Okay, can somebody get me the answer? Sabrina? Sabrina?
If I'm not mistaken, for 49,
49?
8.7.
49? Point?
498.7.
498.7. Okay, is this correct? Anyone else? Junho, what do you think? Junho? Junho, are you here?
Yes, doctor.
Okay, so what's your answer? Is it the same? Okay, which one? Okay, can somebody please say something, right? So otherwise I wouldn't.
Doctor, I think a lot of us got 13.28.
Which one? For this one? S
Yeah,
square.
the S square, yeah.
13 point?
13.28.
Okay, all right. So therefore, in order for you to find S, so you need to square that number. So what do we get? Nabila. Nabila, what do you get?
Yes, doctor.
Berapa ni? Tolong kirakan square root 13.28.
3.64.
Okay, all right. So is everybody okay with that answer?
Yes, doctor.
Okay, good. All right, so we stop here. And then what you need to do, people, you need to continue doing the question. Okay, for calculate the standard deviation, we have done it. And then I would like you to compute the skewness and draw the curve, how it looks like. And then I also would like you to try exercise number 2, right? So that one you need to do on your own. Okay, so let me share with you the attendance. Okay, we do section 1 first. Can you see it on your screen? Yes or no?
Yes, doctor.
Okay, good. Oh. Okay, please be quick. Okay, for those who already scanned your attendance, you can leave the class. Okay, I'll see you again Sunday next week.
Thank you, doctor.
Okay, you're welcome. Bye bye.
Thank you,
You're welcome.
doctor. Take care.
Okay, you too.